my name is Karan Singh, and I'm recording this video for the video video part of this Inverse AI Intern Screening Challenge. So I have chosen a project from this examples given the PDF, and my project topic is this create a LangChain agent that answers question from PDF documents. So let's move to the code. First of all, we have four files, .env and a PDF file and the agent file and the requirements.txt file. The env file will contain our Gemini API key, which will be stored in the environment variables, and we will upload in the main document with the help of the .env module, .env module and the OS module. And the requirement txt will contain all the requirements and the models we are using in this agent making process. So here in this main agent file, we have first of all imported all the modules that we are using in our code, and here uh, load underscore dot env help us to fetch all the environment variables in our code. It helps us to get the Gemini API key that we have stored in the .env file to our code. This helps in the security reasons by not just revealing our private API keys to everyone. So move to the next. Here we have loaded our Gemini API key os dot get env Gemini API key, and here in the 15th line we have given the link of the PDF that we have to perform actions. And next vector, we have given also a path to this vector db underscore dir. Here all the answer that the agent generates are stored in this path. And from this 18th line, data retriever function is defined. Basically the work of this retriever function is to just load the document here and splitting all the text into small chunks. Small chunks are defined by this chunk size and chunk overlap, and these are the separators by which all the chunks are separated on the basis of these notations and um, marks. And all the splitted text are then stored in the splitted text variable, and I have just printed it like that. And here is the embedding model. We have loaded this embedding Google generative AI embeddings model in this embedding model variable, and we have also uh, created a chroma vector storage here, in which we will upload our all the embeddings that we have generated by the text in the documents in different chunks. We will store all that in this vector storage chroma. And here this is the retriever. uh, by using this function, uh, we are using vector store dot as retriever search quark k is equal to 4. Basically uh, this means, and now here is the retriever which will retrieve from this vector storage according to the text we are giving to this function. uh, Now starts the main block. Here we are using the uh, try and accept for the error handling. Mm, Here we have called the data retriever function here, and if this fails to execute, then this exception block executes. Here it will print error while loading document. Please ensure that, and it will print all the details here and then exit from the loop. And if it runs successfully, so it will create a LLM variable where it will call the chat Google generative AI model. Here we are using the Gemini 2.5 Flash as it is very fast and gives pretty accurate answers. And we have mm, taken temperatures equal to zero because we need very precise answer just from the PDF. Uh, it uh, it controls the randomness and its thinking outside the PDF. We have completely blocked it inside. We have completely blocked its scope till the PDF. And here we are defining the template of this model by giving a prompt. You are an assistant for question answering task. Use the following retrieved context to answer the question. If you don't know the answer, then just say you don't know. Keep the answer concise and accurate. And uh, mm, this is the format in which it will generate answers. And next, here it is rag chain variable, which is defining the rag chain that is using the LangChain expression language. In this language, all the statements are separated by the pipe symbol. Mm, Here is this first statement in which there are two arguments. So here is our next is our rag chain variable. It is defining the rag chain and which is using LangChain. Here it is the rag chain variable that is defining the rag chain, and it is using the LangChain expression language. In this language, all the expressions are defined by a pipe symbol between them. Here, first expression is this context retrieval runnable pass through question runnable pass through. Here, this the runnable pass through function used here. It will take the question from the user input and it will assign to this question variable, and question fetched question is also passed to this context, which will be used by the LLM model in the next expression. It will also take the reg prompt, which is defining the template of the model, and we will also define the LLM, which is the Gemini 2.5 Flash model. And at last, we will also assign it a output parser. Here we are using str output parser. Its function is to just uh, cleanly output the code. And now here finish the code of the agent is finished. Let's test the mm, whether our agent is performing well or not. So we are giving it a query like what Mike Tyson said. And if you look into the PDF here, here here it is a line. Mike Tyson said discipline is doing what you hate to do, but doing it like you love it. So let's ask our agent whether it. So here it will first print the query that we have given to it, and it will generate a response by this line. This is the rag chain variable, rag chain, and we are using dot invoke function on that, and we are passing the query that we have asked to it, and then just printing the response. So I have executed this program. So here is our output that agent has generated. So this is correct. It means our model is performing well. So thank you.